Hi children, good morning. Good morning to all of you. Welcome to our Saint Clair School online classes children, right? So last few days back we had started one of the concepts, that is the periodic classification of the elements. In that periodic classification of the elements we taught a lot of points children, right? So regarding that periodicity, then what is meant by periodic properties and what we have the periodic properties. These all points we discussed already, right children? And recently we are discussed about one of the periodic property, that is the atomic size, and after that what are the types of atomic sizes and how the atomic size can be varied in periods and groups. And secondly we discussed about one of the periodic property, that is the ionization energy. What is meant by ionization energy, and what are the units of ionization energy, and how the ionization energy will be varied in periods and groups, right children? So today we are going to discuss about one of the periodic property, that is the electron affinity. What children? Electron affinity. See children, so till now we discussed about there are two periodic properties. Those are atomic size. Atomic size. So atomic size in groups, what children? In groups it is increases. In groups it is increases. In periods atomic size is decreases. Right children? And secondly ionization energy. In groups it is decreases. In periods it is increases. Right children? So these are the two periodic properties we have discussed in the last classes, right children? So today we are going to discuss about one of the periodic property, that is the electron affinity. What children? Electron affinity. See children, regarding electron affinity, what is meant by electron affinity means it is the concept of quite opposite to the ionization energy. But here, see children, please observe clear here. What is meant by electron affinity means, in case of ionization energy, what we discussed here, the minimum amount of energy is required to remove the electron from the valence shell of the neutral gaseous atom is called as ionization energy. But in case of electron affinity, see here, suppose if you can consider the one of the atom. Suppose if we can consider the one of the atom. See here, suppose if we can consider the one of the atom. Here we are taking the form of gaseous state. We are taking the form of gaseous state. Suppose if we can consider the atom is, this is the center of the atom, and these are the some electrons are present in an atom. So these are the electrons can be revolve around the nucleus. Right children? Here these are the cells, we have to consider the inner cells. These are the electrons, we have to consider the inner electrons. So this is we have to consider the valency cells. Those electrons we consider the valency electrons. Right children? See here, suppose if we can consider neutral gaseous atom. Neutral gaseous atom. See here, in case of ionization energy, what we are saying here, the minimum amount of energy is required to remove the electron from the valence shell of the neutral gaseous atom. But here, electron affinity means the amount of energy is released. The amount of energy is released. The amount of energy is released when an electron is added to the valence shell of the neutral gaseous atom. Neutral gaseous atom. is called as electron affinity. See children, when an electron is added to the valence shell of the neutral gaseous atom is called as, here when we are adding the electron to the valence shell of the neutral gaseous atom is, the charge of electron is negative charge. The charge of electron is negative charge. Both are what will happen, children? Both are repulsed to each other. See here, one electron is repulsed with another electron. That's why here when an electron is, the amount of energy is released. An electron is released. That means here this is the electron is collided to this is the electron. That's why what we are adding, the electron is collided to what is the electron present in the valence shell. Those two electrons are collided to each other means what will happen here? So initially it can release some energy. That releasing energy we have to consider as a electron affinity. That's why here electron affinity also we are called as a electron gain enthalpy. What children? Electron gain enthalpy. We have to consider as a electron gain enthalpy. Okay children, see here electron, when we are adding the electron, so electron gaining, it can release some energy we have to express in terms of enthalpy, right children? So now here this is the definition of electron affinity. See here, suppose if we can take the electron, in case of electron affinity, suppose if we can take the one of the atom in the form of gaseous state, we have to consider one of the atom in the form of gaseous state. What we are doing here, we are adding one electron to the atom. We are adding the one electron to the atom. That's why, so after gaining the electron, this is the atom will get the negative charge. That means A minus 1 in the form of gaseous state. Then see here, it can releasing some energy. That is the energy we have to consider, say delta H amount of energy can be released. That is the energy is released, we have to consider, say electron affinity 1. That means we are adding the first electron to the valence shell of the neutral gaseous atom. Right children, see here it can form the A minus 1. That means it is the negative ion. What's right? Negative ion. In case of ionization energy, releasing an electron means we are getting positive charge. There we have to consider, say whether it is electropositive charge, there it will form. Here it is electronegative charge will be formed here. This is the electronegative charge we have to consider as a uninegative ion. There we have to consider unipositive ion. Suppose if you want to add the one more electron to the valence shell of the neutral gaseous atom is, already it is the negative charge. See, negative charges are repulsed to each other. Suppose if you want to add one more electron to the valence shell of the neutral gaseous atom is, it is too difficult children. Suppose if you want to add one more electron to the valence shell of the uninegative ion means, we need to apply some more energy compared with the releasing energy. That means to overcome the repulsion forces, we need to give some more energy. Here also it can release some energy. When we are adding the second electron to the negative ion also, it can release some energy, but the releasing energy is less compared with what we are giving the energy to the electron to the valence shell of the neutral gaseous atom. Please understand children here, because of here what I am saying here, initial stage at the EA1 it can release some energy. That's why EA1 we have to consider as a exotic. What children? Exotic. But here suppose if you want to add one more electron to the uninegative ion means it is too difficult. But we have to add one more electron means too difficult means it requires some more energy. This is the charge we have to consider as a Di-negative ion. What's the name? Di-negative ion. Here it is from here onwards. Here also some energy will be released. The releasing energy is lesser than compared with what we are giving the energy. That's why here we have to consider as a negative energy. So it is we have to consider as a EA2. See children, here also some energy will be released. Here also some energy will be released. Compared with these two, it can release more energy. But to addition of electron, it requires more energy. That's why addition of electron, it requires more energy means compared with releasing energy, addition of energy is more. Here means we have to consider as a EA2, we have to consider as a Endo-G. What's your name? Endo-G. Suppose if you want to add one more electron to the di-negative ion, A minus 2 plus 1 electron means it is too difficult, children. It is too difficult. But here it is too difficult also. Suppose if you can add one more electron means it is impossible. It is impossible. But we need to add one more electron. So it is too difficult means suppose when you are adding one more electron here, it can form tri-negative ion. What do you mean? It can form tri-negative ion. So here also it can release some energy. So that is the energy we have to consider as a electron affinity 3. When we are comparing with EA1, EA2, EA3, these three energies EA1, EA2, EA3. Here EA1 is exergy, EA2 and EA3 we have to consider as a Endo-G. What's the name? Endo-G. Compare with these three energies. See here, compare with electron affinity 1, electron affinity 2, electron affinity 3. Among these three energies, which is the energy very high, children? Here, it can release some less energy. It can release some more energy. Here also, the releasing energy is very less. But what we are giving the energy is very high. That's why here EA3 is greater than that of EA2 than EA1. That means this is the order we have to consider as a electron affinity. EA1 less than that of EA2, EA2 less than that of EA3. Or we have written as EA3 is greater than that of EA2 greater than that of EA1. Right, children? So whether like this or like this we have to write. Right, children? So this is about what is the definition of electron affinity, what is the electron affinity 1, what is meant by electron affinity 2, what is meant by electron affinity 3. So then here the units of electron affinity also, this is also we have to consider the energy. That's why what are the units for the ionization energy? The same units are there for electron affinity also. Right, children? So here also electron affinity units are kilocalories per gram atom or kilojoule per gram atom and electron volts. These are the units of electron affinity or electron gain enthalpy. Right, children? So today what we discussed, children? So today we discussed about what is meant by electron affinity. Here the amount of energy is released when an electron is added to the valence shell of the neutral gaseous atom is called as electron gain enthalpy or electron affinity. Right, children? So now coming to the what are the factors can be affecting on electron affinity? What are the factors can be affecting on electron affinity? So children, what are the factors can be affecting on electron affinity? See here, what are the factors can be affecting on electron affinity means what are the factors are there for ionization energy. Here also we have to consider the same, but some little bit changes are there, children. See here, what are the factors affecting on electron affinity? Factors affecting on electron affinity. What are the factors affecting on electron affinity means the first one is atomic size. What's your name? Atomic size. Second one is nuclear charge. Second one is nuclear charge. And the third one is Here screening effect or sealing effect. Screening effect or sealing effects. These are the three factors can be affecting on electron affinity. Right children? See here, in case of atomic size. In case of atomic size. So when we are moving from top to bottom, what will happen children in the growth? The atomic size is gradually increases. Atomic size is gradually increases. See here, when the atomic size is increases means what will happen here? The force of attractions or decreases. Force of attractions are decreases. When the force of attractions are decreases means screening effect is increases. Screening effect is increases. So screening effect is increases means here what will happen here? Here the force of attractions are very high, but here the force of attractions are very less. Suppose if you want to add the one more electron here, what will happen here? When we are adding one electron here, it is having more repulsion forces, it can release more energy. But here less repulsion, less attractive force, less force of attractions are there. Suppose if we can add one more electron here, it can release some less energy. That's why from top to bottom in groups, when the atomic size is increases means here electron affinity is decreases. Electron affinity is decreases. Here from left to right in periods, what will happen children? From left to right in periods, the atomic size is decreases. Here more force of attractions are there. The nuclear charge is very high. Screening effect is decreases. Then atomic size is decreases. Here when the force of attractions are increases means automatically the addition of electron also it can easily added, it will easily gain. That's why the repulsion forces are more here. That's why here the releasing energy is also increases. That's why here from left to right in periods, here electron affinity values are increases. That's why here if the atomic size is decreases means electron affinity is increases. If the atomic size is increases means electron affinity is decreases. That's why atomic size is inversely proportional to the electron affinity. Atomic size is inversely proportional to the electron affinity. Right children? Now nuclear charge. From top to bottom in groups, what will happen children? Nuclear charge is decreases. So nuclear charge is decreases means electron affinity also decreases. Here the nuclear charge is increases means electron affinity also increases. That's why nuclear charge is directly proportional to the electron affinity. Nuclear charge is directly proportional to the electron affinity. Right children? And now coming to the screening effect. From top to bottom in groups, screening effect is increases, electron affinity is decreases. From left to right in periods, screening effect is decreases, electron affinity is increases. That means it is decreases means increases. Here increases means decreases. That's why here also screening effect is inversely proportional to the electron affinity. Right children? So these are the common factors can be affecting on electron affinity. But here we need to observe one thing children here. In some cases, what we are saying here, electron affinity values. Electron affinity values for EA1 is always exotic. EA1 is always exotic. But EA2, EA3 are endogic. EA2, EA3 are endogic. And here, from top to bottom in groups. From top to bottom in groups, what will happen here? Suppose if we can take here beryllium, magnesium, calcium, strontium, barium, radium. So these are we have to consider second A group elements. Then here boron, aluminum, gallium, indium, thallium, carbon, silicon, germanium, tin, lead, nitrogen, phosphorus, arsenic, strontium, bismuth, oxygen, sulfur, selenium, tellurium, polonium. Then here fluorine, bromine, iodine, acid. So these we have to consider the second A group, third A group, fourth A group, fifth A group, sixth A group, seventh A group. Right, children? So from top to bottom in group, general what I am saying here, from top to bottom in groups, electron affinity values are decreases. From top to bottom in groups, electron affinity values are decreases. But you should observe clearly, children, here. So beryllium to magnesium. So at a time, how many electrons are increased here? 8 electrons. Here also 8 electrons. Here also 8 electrons. That means, so actually generally from top to bottom in groups, atomic size is increases. Here at a time 8 electrons are entered into the second cell means the atomic size is varies will be takes this. So at a time the atomic size is increases means that's why compare with these are the elements we have to consider as hydrogen, helium, then lithium, beryllium. Here second period it is we have to consider as second period and it is we have to consider as third period. Compare with the second period and third period elements. Third period elements having more electron affinity values. Third period having more electron affinity values. That's why here we have to consider chlorine having more electron affinity than fluorine, then bromine, then iodine. Chlorine having more electron affinity than fluorine, then bromine, then iodine. See here oxygen. Here in case of 6A group elements, sulfur having more electron affinity values than oxygen, then selenium, then tellurium, lastly polonium. Similarly, suppose if we can take nitrogen. Here nitrogen and phosphorus. Phosphorus having more electron affinity than nitrogen, then arsenic, then strontium. See here in case of both the group elements, silicon having more electron affinity than carbon, then germanium, then tin. Suppose if we can take the boron and aluminum, aluminum having more electron affinity than boron, then after gallium, then after indium. Right, children? See here beryllium and magnesium. Magnesium having more electron affinity rather than beryllium. Then after calcium, then after strontium, then after barium. So this is a little bit change will be happen here, children. So general what we are saying here from top to bottom in the groups, electron affinity values are decreases. But when you comparing here, just little bit change from second period to third period. Third period elements having more electron affinity rather than secondary period. And from here onwards, it is commonly electron affinity values are decreases. Right, children? It's very important, children. In the periodic table, so the highest electron affinity element is fluorine. Which is the element is the highest electron affinity element, children? Fluorine is the highest electron affinity element. Right, children? So from top to bottom in groups, some little bit changes is there. It is the little bit change. So initially the electron affinity values are what will happen here? The third period elements having more electron affinity rather than second period. From here onwards, it will be decreases. Okay, children. This is about groups. And in case of periods, commonly we have to say that here suppose if we can take from left to right hand periods, what will happen, children? The atomic size is decreases. When the atomic size is decreases means automatically. And the atomic size is decreases means electron affinity values are increases. Right, children? Fluorine having more electron affinity than oxygen. Oxygen having more electron affinity than nitrogen. Right, children? But compare with groups here, compare with fluorine having more electron affinity than fluorine. Okay, children? This is about how the electron affinity will be varied in periods and groups. And see, children. See here finally in this concept we will discuss about small points, children. So see here what I am saying here, in case of EA1 values are always exogenous, but EA2 and EA3 electron affinity and electron affinity 3 values are endogenous. But here some cases children, EA1 value is also endogen. What are those elements like? Suppose if we can take noble gases. Suppose if we can take noble gases. What are the noble gases? Helium, neon, argon, krypton, xenon and radon. So these are the elements having here. Suppose if you want, these are elements having stable electronic configuration. So it is too difficult to addition of electron to the valence cell of these noble gases. That's why here from EA1 onwards it is the endogic values. What's your name? Endogic values. And some cases like beryllium. Already beryllium is fulfilled with 2 electrons in the s orbital. That's why there is no chance to addition of one electron. And suppose if we can take magnesium also, here neon creates 2. There is no chance to addition of electron to the s orbital. So in this particular case, some cases here EA1 value is always endogen. Sometimes the noble gases having electron affinity values are 0. Electron affinity values are 0. Here for noble gases, sometimes electron affinity values are 0 also. That's why children. So this is about one of the periodic property, that is the electron affinity. Right children? So till now what we discussed here, there are 3 periodic properties discussed here. One is the atomic size, second one is ionization energy, third one is electron affinity. Right children? So please all of you maintain the CW and each and every point you have to write in your CW. Okay children, we will meet in the next class. Okay, please children, stay home, stay safe. Thank you.